dear student, I'm Mr. Kutwala from Educatiz. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on the topic of wave for the subtopic of the wave motions. So before we proceed with our discussion, my dear student, we should remember where we ended on the last session. So on the last session, we tried to discuss how we obtain the frequency, the general formula of the frequency for the NC harmonic. And we said that for the NC harmonic, the frequency of the NC harmonic must be equal to the number of the harmonic times the frequency times the velocity divided by the 2L. That is the formula that we demonstrated on the last sessions. And after there, we said that, my dear student, if the number of harmonic is equal to 1, now we should obtain the fundamental frequency or the first harmonic, which can be expressed by saying that the fundamental of first harmonic must be equals to 2L divided by must be equal to V divided by the 2L. That is what we demonstrated on the last session. And finally, we said that for the second harmonic, this is the first overtone. The fundamental, the frequency of their frequency must be equals to the 2 times the fundamental frequency of the first harmonic. Also, for the third harmonic or the second overtone, it is a frequency must be equals to 2. It must be equal to 2 times it must be equals to 3 times that fundamental frequency. Generally, we concluded by using the figure that expressing the vibration of the node on a straight string. That is what we concluded by saying that the length must vary. Length atakuwa for the first harmonic atakuwa ni sawa na wavelength divided by 2. For the second length atakuwa ni sawa na wavelength. Lakini for the third length must be equals to 3 over 2 wavelengths. Finally, we say that with respect to the tension, now the frequency of the NC harmonic must be equals to 1 over 2L times the radical of the tension divided by this linear mass density. So today, let us proceed with our discussion for this example related with what we learned on the last discussions. We have our example number 6 for the topic number 8. And our example said that a thin wire of length 75.0 centimeter has a mass of 16.5 gram. Kwamba we have the thin wire, and that a thin wire having the length of this 75.0 centimeter as we have been told. So the wire having the mass of 16.5. Kwa ule wire ulikuwa na mass ya 16.5 gram, my dear student. One end is tied to a nail and at the other end is attached to a screw. Kwa end moja ilikuwa imefungwa. It tried to be tied to a nail. Kwa kwenye ukuta tu kwamba kuna msumari pale wakafunga pale. Walipofunga pale kwenye one end, na baada hapo wakachukua wakatouch kwenye screw. Screw ni kitu ambacho kinakuwa kina uwezo wa rotate. Kwa hiyo wali attach kwenye screw kama anavyosema, my dear students, that can be adjusted to vary the tension. Kwa hiyo hapo ilikuwa wanajaribu kuadjust ili kuweza kutengeneza ile tension, my dear students. So to what tension must the screw be adjusted so that a transverse waves of wavelength 3.33 centimeter can make 3.33 centimeter makes 875 vibration per second. Ndio kitu ambacho tumeweza kuulizwa hapa kwenye hii discussion yetu, kwamba tuna thin wire na ile thin wire ina comprise of the length which is equal to 75 centimeter and also contain the mass which is equal to 16.5 gram. Now one end is try to be tied on the nail, and also the other ends on the screw, and trying to be rotating, vibrating. Akajaribu kuanza kuivibratisha, kuadjust. Alipokuwa na adjust ile tension ilikuwa inabidi formed kwenye ule wire as we have been told. And this screw obey the transverse waves of the wavelength at this one. They form the wavelength which is equal to 3.33, and make also this make the vibration per second which is equal to 87.5 as we have been told, my dear students. So after that, what we are supposed to do here is to record the data that we have on our equation. So on our equation here, we have the length of the thin wire, and also we have the wavelength of that thin wire, the wavelength that is formed there. Also we have that frequency, the frequency, the number of vibration. Now how can we obtain this tension, my dear students? So first of all, from the equation number 4 for the topic number 8, let us record the equation number 4 for the topic number 8. And our equation says that the velocity must be equal to the radical of tension divided by this mu, which implies the linear mass density. So after there, and this one we have been told that and this velocity might be equals to frequency times the wavelength. Kama huyu velocity ni sasa na radical of tension divided by mu. Pia huyo velocity tunaweza tukampata kwa kuchukua frequency tukamzidisha na wavelength, my dear students. So after there we should turn back here. We should come here. Now since we are supposed to do is to take the value of V and substitute into this formula. Utamchukua huyu hapo tutamsubstitute, na baada hapo tutaondoa radical upande wa kulia tuweze kumpata huyu attention. Tuta apply square both side. Tukisha apply square both side tutapata kwamba frequency square times the wavelength square is equal to the tension divided by this mu, by this coefficient, by this linear mass density. Lakini tunachokitaji sisi ni tension. Cross multiplication utakuja utapata kumbe tension is equal the tension must be equals to frequency square wavelength square times the linear mass density as we have been told, my dear student. But after there, we know the formula of obtain the linear mass density, which is equal to length divided by the mass. Kwa tutamsubstitute pale, ukimsubstitute ndio utapata hii formula ambayo ameweza kuipata hapa kwamba kumbe the linear mass the tension of the string, my dear student, must be equals to the frequency square times the wavelength square times the mass divided by the length, my dear students. So after this one, let us substitute our given value. Tutachukua zile value tutasubstitute hapa ili tuweze kupata kile ambacho tumeulizwa hapa. So if we do that, my dear student, we should obtain that this tension is equal to 75 reciprocal of the second. Then bracket a square because this is the frequency we have been given, which is equal in vibration per second. Kwa tukisubstitute pale tutapata. And also instead of that in the wavelength, we should take the value of the wavelength and place it into our formula. Kwa tutamchukua ile wavelength tutamsubstitute pale. Ukishamsubstitute ambayo ni sawa na 3.33 exponent negative 2 meter. Then mabano a square times the mass. Mass, we have the value of the mass which is equal to 16.5 but a gram. Now let us change it into the kilogram. Itakuwa ni sawa na 16.5 exponent negative 3 kilogram, my dear students. So divided by the length, the value of the length we have which is equal to 75. Kwa tayari value of the length tunaye ni sawa na yule 75 my dear student exponent negative 2 meter. Kwa tukisha substitute pale tutapata sasa kumbe yule tension ni sawa na if you take your calculator and substitute all of this value, utaweka mabano kwanza kama nilivyoonyesha pale, weka mabano alafu ingiza value yako, funga mabano alafu weka square exponent pia na pale the same way. Mwisho wa siku utakuja utapata kumbe thamani ya tension ambayo tulikuwa tumeulizwa kwenye swali letu is equal to 18.7 Newton. And finally, you should conclude by saying that therefore the screw must be adjusted to 18.7 Newton in order to transverse the wave of wavelength which is equal to 3.33 centimeter and making 75 vibrations per second. This is what we should conclude by saying, by using this statement, my dear students. So after there, my dear student, let us stop here. We could come and proceed with the next part here.